is an angle. So first of all, it's an angle. And that angle is always with the north, measured clockwise. So I like to think of a bearing as an angle formed with the vertical. So when we're talking about a bearing, it's always with a vertical. The other thing that makes a bearing different is that you have to include direction. And I'll show you an example of what I mean by that here shortly. Okay, so let's go ahead and get started. And then you'll have a chance to do a couple on your own. Oh, also, before I forget, homework 13 is due Wednesday. I did change that on Canvas. Originally, it was due tomorrow, but I did move the due date to Wednesday. It's out of the book. Okay. So let's go ahead and get started. So thinking about our compass, never eat soggy waffles. I don't know if that's how you all learned it, but that's how I remember it. So we have our compass. It says that we have a plane. The plane went south, which would be this direction. And then it turned and went to the east, which is this direction, from Cleveland. So this is Cleveland. And right now, this is our plane. It's asking what bearing should be taken in order to fly back to the airport. So this would be the direction that we're going. So here's the thing. Most people would think, oh, okay, that's this angle here. But that's not what we're looking for, because is that angle formed with the vertical? No. That's an angle formed with the horizontal. So truthfully, what we have here, the bearing would be here. That is your bearing. Okay. So thinking back to geometry, alternate interior angles are congruent. So this angle here is going to equal the same as this angle because they're alternating interior angles. So these two angles are congruent. So let me go ahead and put my miles. So first we went 80 miles south, and then we went 95 miles east. What is our bearing? Also keep in mind that this is really two rectangles together. Okay, so this is my 90 and so is this. So opposite sides are congruent, so I could put my 80 here and I can also put it here. All right, so what trig ratio do you think we're going to use? If I'm looking for this angle, what trig ratio am I using? Am I using sine, cosine, or tangent? Tangent. 95 is opposite the bearing. Well, opposite. 80 is adjacent. And remember that whenever you're looking for something inside, we have to use an inverse. So we would do the inverse tangent of 95 over 80. So type that in your calculator. Yes. So rounding to the thousands place would mean I would need 3 decimals. So it would be 49.899 degrees. Who got that in their calculator? All right. So the thing about a bearing, going back to our definition, is that it has to include direction. So if I'm going back to the airport, keep in mind that originally we went south and east. But if I'm going back, what direction do you think I'm going to go? North, west, right? That's why we put our north, south always goes here, and east, west goes on the right. This is the direct or the correct way to write a bearings. You have to include directions. And whenever you write a bearing, again, this side is either going to be north or south whenever you're talking about a bearing. And then on the right side is either east or west. All right, let's go to number 2 and practice a few more. And then you'll have a chance to do a couple on your own. So we have a ship. A ship leaves the port and it goes 12 miles to the west. So here's our port. So leaving the port, it went 12 miles to the west. And then it turned and goes north for 20 miles. So notice that right now where we are, when it heads back, this would be my bearing right here. Go ahead and find your bearing. So your angle is inverse tangent 12 over 20 because that would be opposite over adjacent. So you should get 30.964 degrees. And what would be my direction heading back?
Southeast.
South and east. That's it. That's all is to it. All right, we're going to do 3 and 5 together. And then you're going to do 6 and 7 on your own, and then we'll end there. We're going to skip over 4. We might do 4 tomorrow. Let's look at number 3. It says an airplane is 30 miles northeast. So noticing that this is 2 directions. It's not north, it's not east, it's northeast. That's how I know this is the hypotenuse. Because it's going at an angle, or it's going at a diagonal. So it didn't just say north, it didn't just say east, it said northeast. So we have an airplane and northeast would be this direction. So it's going this direction, 30 miles. So this would be my airport. And then up here is the plane. And it says that it has an angle of depression. Now, angle of depression is not the same as a bearing. That's formed with the horizon. So we're going to go this direction. Oops. And it would be 32.5. All right, so if this is A and this is B, I'm just going to label that. You don't have to label that part, but it's asking what is the plane's altitude. Does anyone know another word for altitude? Height. So which side do you think I'm trying to find? A or B? And I just assigned A and B. It could be X and Y, W, and there's no reason why, but B. Yeah, so we're trying to find this side because this is my altitude. So I want you to look at that, label your sides, adjacent, opposite, hypotenuse, and I'm going to ask you a question in a minute. All right, who's going to use tangent? Who's using cosine? Who's using sine? I will use sine. So this is opposite of my angle. And we already established that this is the hypotenuse. So that would be a sine. So sine of 32.5 equals opposite over hypotenuse. Go ahead and solve that for x. Hold on 1 second, sorry. This is Miss Frank. Can I send her in about 15 minutes? Okay, sorry, what was your question?
I don't know if this is a dumb question, but like, I thought we were supposed to find,
You said you thought we were going to find the angle?
like, what was the next thing?
Oh, you mean this right here?
So, yeah, and then use 30.
When you think about height, height is always vertical. So if I'm asking you how tall something is, that's the vertical side. Yeah. And I said that because it said north and east, that's how I know it's the hypotenuse. That's how I know that this is a diagonal line, not a horizontal or vertical line. So what you should get, and again, we're not looking for a bearing. We're looking for a distance, and it's 16.119 miles. So we're going to skip over 4. We might come back to it later, but let's look at number 5. So it says we have an airplane, and that airplane is 15 miles. The airplane I'm sorry, let me read it up. Okay. An airplane is 15 miles from the airport at a bearing of north 62 west. Okay. So we have our airplane. So this is our airport. And it's, well, actually, let me put it over here because it's going northwest. So we have our airport, and it's going northwest 15 miles, and it gave us our bearing. And the bearing is always with the vertical. So the bearing that they gave us is really here. But because of what we know, that's a very ugly drawing. Let me make that a little bit better. Hold on. Because of what we know that alternate interior angles are congruent. So this is my right angle. And so when they give you a bearing, I know that that bearing is really going right here. That's my bearing. But in relation to my black triangle, that would be the same as putting it here. And it said that it's 15 miles. So that's 15. That's my hypotenuse. And it's asking us to find how far due west. So I need to find the west distance, and I need to find the north. So keeping this as my angle, I have my hypotenuse. So west What would I use to find west? Sine, because west is opposite, and I know my hypotenuse. So to find west, it would be the sine of 62 equals opposite, so I'm gonna put a W over hypotenuse. And then to find north, what do you think I'm gonna use? Cosine. So to find north, it would be cosine 62 equals north over the hypotenuse. All right, so go ahead and solve both of those. Ariel, can you grab that calculator?
Thank you.
So for the west, you should take 15 sine 62. I got about 13.244. And that's miles. For north, I got about 7.042 miles.